So, hello, my name is Philippe Cascra, and I'm going to talk to you about debugging hardware. Hello, my name is Daniel Haight. I'm going to talk to you about learning security by being a smiling imp. I want to stress that this is not by being me, by being an imp, an emoji character. So me, imp is a little mischievous. They may have got their hands on an iPhone. It might have been stolen, but don't judge. There's no evidence. It has no real regard for consequences, and the imp is absolutely not me. I'm trying to do a talk. Allow me. I'm sorry. One thing is, imp is pretty curious about how things go on as well, and the why is left to people with bigger ideas. So to start off with how, we start with baby steps. Excuse me. The imp has a general idea of an app. It looks like this. Is really simple. Unfortunately, the imp didn't attend Daniel's talk yesterday because it was ill or a terrible person or both, but it did read the title, and so it's aware of HTTP. And those arrows are probably HTTP. Simple. So we want to see what's going on there. And we start by going to Google. I don't know how you all do your stuff, but that's how I do it. I charge a fee for it too. It's great. So we've gone to Google. I've just searched, how do I find out what's going on this HTTP connection? And I've come to an article which says that you need to install Charles, you need to join the same network as your device, you need to set up an HTTP proxy from your device to the computer that you're looking at it on, and then you're going to see all the requests come through. I don't know what much of that means, but I just set it up, and I've got Charles running, and it feels okay because the fake shine on the selectable UI elements looks a lot like the head on the imp. But I've read this blog post, and I've got HTTP traffic going through Charles proxy. And then I find out a bunch of these question marks. I feel like Charles is taunting me because I don't actually know what's going through. I thought I would get all the juicy data, all the Facebook posts, really know how that data is structured, but I just got question marks. The imp doesn't know about Unicode and its difficulty therein either. So yeah, I'm confused. I don't know what I'm looking at. I don't know if you see, but I see github.com. So like something's happening, but I'm not seeing what I want. So I Google again, and there was an almost clap there. Thank you. I come across another article that tells me Charles has an SSL proxy. That's great. I turn that on. You need to download and trust some certificate. It's great. I do that. And then you need to turn on the SSL proxy in the Charles settings. And so I've got a little asterisk here, which is you shouldn't always do as the imp is doing right now. Blindly trusting a certificate is not the best idea. But the imp doesn't know or care. Because we're seeing plain text coming through now, right? This is just the GitHub API, it's over HTTPS. But instead, we've got Charles's SSL proxy set on. We've blindly trusted a certificate on our device. We're essentially manning the middling ourselves, but we don't care, because we can see plain text. And I just want to point this out as well, that you can see that the imp is not actually me. It's also a success baby. Oh. So this is all well and good, an excuse for that kind of rush through there, because I don't know how many of you have done this before. Probably a lot of you do this quite regularly. But now we get to our next kind of stop, right? We've hit a hole, because some sneaky apps, like all the good ones, we still can't get connections through. And because we were in Daniel's talk yesterday, or at least you were, you know that that's because they were pinning their certificates. The imp doesn't really know what this means, but it's stopping him from seeing what he wants. I could say you should pin your certificates, but I promised myself I'd only use one emoji in the slide, so I'm just going to say pin your certificates. So now we need to get into this. We need to circumnavigate the SSL pinning. So I vaguely know how to do this in my app, right? I've seen the docs. I have this API, and this is where I receive this challenge from the challenge parameter, and I check whether or not it has the same, or is signed with the same signature as the certificate I have in my bundle. And that's great. That's how you do it as a normal app developer. I don't want that. I want that to fail. So I just want to say, use the credential, whatever it is. If any of you are familiar with the anime One Piece, we now have a time skip. During this time skip, I've done a lot of training. I've spent a lot of time on iPhone Dev Wiki. And we find out that it turns out we're going to have to jailbreak our device. We can jailbreak our device. Well, what's this going to allow us to do? We'll follow some steps. We jailbreak the device. We can then install OpenSSH on this device and SSH into our iPhone. The root password is Alpine. You should probably change that when you first SSH into it. There are instructions on how to do that on Cydia, which will come when you jailbreak and other things like that. But the imp didn't, it just kept it as Alpine. We can re-sign the debug server and SCP it onto the device and attach to any process. Now the debug server is a tool that comes bundled in Xcode, and that is the part that's on the device or running attached to a process in the simulator when you're debugging from Xcode and you're in this LLDB window. Debug server is what that is talking to. We can attach it to our favorite process. This is what that looks like. The port number is the port number that you're listening on, and I put star so that anyone can connect to it. Again, the imp is pretty reckless. There are ways to circumvent that, by the way, that you can do as an app developer, but I'm not really going to tell you because I want to get in. This is not true. I will have some slides at the end which will tell you more about it. But the imp won't tell you. So once we're there, if you've had any experience with LLDB, you can call this command, which is dlopen, and what this will do is open a dynamic library for you. So essentially, all you need to do is create a dynamic library which just overrides the implementation of the URL session did receive challenge or the URL session task did receive challenge, and you just return it to return yes. A really good example of this, or just generally loading code into an application that isn't yours in general, is something that I like to call all your images are my cats. And I would have loved to show it to you. And I will, but very shortly. So if you please go to github.com/Daniel1of1/NSSpain 2015, you will see that there in a few hours, maybe tomorrow on the weekend, I'm not sure. But this would just be a demonstration of having some code that will override basically the default or the initializer for UI image, image named, and return you an image with the data of my cat. So just a quick recap on what we've been able to do there is we've followed the imp briefly through a journey that is mostly filled with holes. I'm sorry, but we can deduce a few things. As much as you may want to believe, there is no such thing as a client-side secret. Given that I can attach a debugger to your app and/or manipulate your app at runtime, if there is anything that has to be unencrypted at some point, or has to be used by your app, and it's unencrypted at some point, then I can have access to it. So any attempt you do to obfuscate something within your code is possible to get around. Now the caveat here is with infinite time. You can do a lot to prevent people from fiddling around with your binary. For example, you can prevent people from attaching the debugger, but then there are ways around that. You can obfuscate certain things when a debugger is attached, but there are also ways around that. Because as someone with root access, I can tell your app that the debugger isn't attached, even when it is. So what's important to remember about that is, I mean, this isn't a blanket statement that's saying you shouldn't ship whatever, but if the value of any secret that you're shipping in your binary is greater than the cost or the average going rate for a black hat hacker, then you should reconsider, really, because that's just a market opportunity. Right. Any attacker who has jailbroken their device has stronger permissions than you because they have root access, and given that you are running on the mobile user, which has significantly less privileges, and that you've had to, more than likely, if you've come from an App Store distribution, your powers have been severely limited by Apple. So as much as you can do, there are plenty of ways to check if device is jailbroken, but with any sufficient effort, these can be circumvented. There will be much more of this here again shortly. This is mostly to prevent me from bombarding you with code, also because I've been kind of ill. I haven't got around to finishing all of it. But there's another thing here, which is probably the more important part. So if a user is using your app and they put data into your app and you save it on the device, how could you possibly keep it secure? And I can say that, well, I mean, that'll work, right? Sure. You know, just use Apple's recommended, the most highly secure APIs for data saving. However, whatever file protection you use, in the worst case scenario, an attacker has a jailbroken iPhone with your user's data on it, which means they've already got past the passcode lock. So all of that is pretty redundant. However, you can actually keep your user's data safe, I promise. You can reliably secure it on an iOS device if you assume it's not jailbroken when the user first encrypts whatever data you're getting, because otherwise you have no way to verify that it's not jailbroken and that someone else isn't seeing what you're seeing in the same runtime. Okay, so then you assume that the hardware stack is completely secure, which is up to you to decide. You then assume the software stack is completely secure and not compromised, which is totally legit. You then have the user enter a password. With this password, you generate an encryption key with PBKDF2 using the password and a random salt. Without the random salt, you lose a lot of entropy and it becomes much easier to brute force. You encrypt the data with that key using AES-256. This is the same as the hardware encryption used on the iPhone in the first place, using a random initialization vector. With this key and another random salt, you generate an HMAC. You will use this to verify that what you actually decrypt later is what you encrypted in the first place. You have to keep the initialization vector, the salts, and the MAC. But the thing is, in the worst case scenario, the user has access to, or the attacker has access to the app's runtime. So they already have access to the IV and the MAC and the salt, which means the only thing they have to brute force is the password. And because you asked a human to enter the password is 123. So we should probably talk about humans, because unfortunately they seem to be the weakest link in any of our cryptography. I say, in some ways, it's pretty easy that for most of us, we're dealing with what is client-side security, right? So if there is like a data breach, it's one person's data breach as opposed to like 11 million Sony, Adobe, Ashley Madison, Sony again, people. And Apple have done a huge amount for us. I mean, with very simple NS file protection APIs or just setting those policies, you get a free AES-256 encryption for nothing, and you just assume that your device is locked, which for some people, unfortunately, is a bad assumption. But we're as much as what we do can't necessarily affect 100 million accounts on the server, we can still affect that one account. And for the one person that has their data breached, it doesn't matter whether or not that happened on the server or on the client, their data is still breached. And unfortunately, like, one of the best things and the worst things we have for this is passwords, or password 123s. And I said before that we have, Apple has done us a huge favor with literally free hardware encryption, assuming that the user has locked their phone with a secure passcode. Now you get 5 tries to open up the phone, or 10 if you can wait a bit. And if you try the top 10 passwords, these are the top 4, made up by me, but I'm sure they're pretty accurate. You can get into someone's data, and around 15% of everyone's passcodes end up being somewhere in the top 5 or the top 10. So it turns out we're pretty bad at passcodes and passwords. And in fact, we're pretty bad at random. So one thing I want to talk about briefly is a thing called brain wallets. If any of you are familiar with Bitcoin, wonderful. So there's in the Bitcoin ecosystem, you'll have an address and a private key. The private key is required to sign transactions, which is to send money out of your account, which is like the important thing you want to do, aside from getting money into your account. So what brain wallets are a secure passphrase, and this passphrase can be anything. It could be a poem that your mother used to sing to you at night in a language that wouldn't necessarily be English, for example. So you might think that this is a pretty strong, like a pretty random piece of data, right? And it goes through a lot of mathematical functions to get you your private key, so it must be pretty random. So you get your passphrase, you generate a private key with that you generate a public key, and with that you generate your address. The thing is, we're really not that random. And it turns out, that one I have a blank slide, yeah, people are really predictable. So at DEF CON this year, just gone, just over a month ago, there was a large amount of money moved. So the presentation was on basically mining brain wallets, so reverse engineering brain wallets, as opposed to mining Bitcoin, because the brain wallets are easier and take less computation. He went through all kinds of common phrases and found in the order of hundreds of thousands of Bitcoins that had one time been in an address, been in addresses generated by these arguably random things. And just over a month ago, he saw an account that had 250 Bitcoins, which at the time was about $22,000 worth. And this is just protected by a really, really strong key. I mean, there's the address space is 2 to the 160. It's really hard to get a collision in that space, right? But this key was generated with an empty string as the input. So when you ask people for secure passwords and they give you an empty string and they keep $22,000 worth of value wrapped up in that empty string, we don't quite get it. Also, it turns out that the best place to get inputs for brain wallets was Wikiquotes, and he just used that as a dictionary attack and it worked wonders. And this is the real reality of it though, right? I'll wait for everyone to laugh. Cool. We're humans, and we're not computers. We're terrible at random, and we're also surprisingly susceptible to wrenches. And we're pretty easily tricked as well. So this is another example, and now this comes into the much more human side of security because you have to deal with them. Now, I'm going to play a little video because I don't believe in live demos. And this is an app that I wrote. I'll tell you, there is a giveaway But you can imagine that, so this is my actual Spotify account. And if I play this video, I'm going to log in with Facebook, which is a pretty standard thing to do. That was the giveaway. And it'll take a minute because I had a pretty slow connection. But it's fine because I want to walk around a bit anyway. Wonderful. So, I logged in, that's fine, but I didn't go to Facebook to authenticate. I went to my own app, which was called Steal FB Credentials. And that was pretty easily done. Now, a quick explanation on what happened there. I registered for FB Auth 2 and FB Auth, which are the URL schemes that the Facebook app registers for, and a few others. And then all I did was I took a user through the website authentication flow in a web view, and I, before then clicking OK, which has the redirect URL back to Spotify, I take from that URL the access token. And to go one further, if I had gone through the process where I would have the user enter their username and password, then I can just take that from the fields using executing JavaScript on the web view. So this specific attack can be prevented. It wasn't in Spotify, but it is in Pinterest. And in the newer handle URL, you have a parameter which is sending app, the app that's sending, or the app that's opening that URL, so you can detect whether or not that URL is coming from Facebook or not. However, if you do, on your malicious app, change your bundle ID to com.facebook.facebook, that will still work. So a problem we have with a client as the client for a user is sometimes we can oversend things. We have unprecedented access to a lot of really, really personal information, and this is a big responsibility. I'm not even going to touch on things like health kit data, in which there could be some quite serious issues with if any of that were to leak. But I'll focus on Tinder. So this was a vulnerability I think about 18 months ago, and what was interesting is that using techniques previously described with Charles, you can see that a typical request for a user on Tinder looks like this. What's interesting, and you can see that on the cards, you get how far away your potential match is. And if you'll see there on the distance_mi, that's a really, really, really accurate distance there. Maybe too accurate. So in fact, it is too accurate, because if you have only 3 of those, you can then get the exact location of your potential match. But I don't think they would be happy with that. So you're responsible for these humans that may not understand that an easy password can have similar financial or emotional impact to leaving your front door open in a bad neighborhood. For the people that don't realize access my photos means access all my photos. For the people that are fleeing conflict from the newest oppressive regime, and there's one device that can help them communicate with aid and or be tracked by said regime, hopefully try not to be the one that's allowing them to be tracked. Pre-thanks. So I would really like to thank Luis, Borja, and Philippe for handling my issues last minute so well. And since we're about halfway through the conference, maybe I should say you should give them a round of applause, because they've still got a way to go, but they could do with some encouragement right now. Thank you. I can answer questions, I suppose, if there are any.
Hey, thanks for the talk. But all of this will only work when a user is stupid enough to jailbreak their phone.
Not all. In the situation when you...
Remote code execution and stuff.
Yes, yeah, for all of that, yes. In terms of, so for example, the URL scheme hijacking, as it's normally called, that doesn't have to be anything. For a lot of things, it's just getting an app on the user's phone, right? And you can imagine that this can be dormant, because you can register a URL scheme in an update, right? So you can have an app that is perfectly fine for a long time, and then switch it to become an interception, even for just one update. And anything that's trying to authenticate through Facebook can go through there. So that's one thing. The other thing is that if you consider that in the situation where a user has lost their phone or has had their phone stolen, the only thing that's stopping you normally is still the 4-digit passcode, which 1 out of 10 times is going to be 111 000 555 1234. But yes, you're correct that none of the remote execution is possible without jailbreak forehand, which requires a lot to begin with.
The other thing, I think Apple said that last year, if you have a 4-digit passcode, even if it's not one of the easy ones, if you have access to just some reasonable compute power, you can brute force that in 8 minutes or something?
Yes.
So the thing is, if you put it to 8 digits, that will then take about 8 months. So that's worth considering if you have any kind of interesting data on your phone. Yeah,
absolutely. I mean, if you're in certain enterprise circumstances, a strong password can be mandated, right? The really unfortunate thing about that is, so really most of the time we're not dealing with brute force, right? We're dealing with statistically informed guesses, and I know several people who have had to have strong passcodes because they work in a big enterprise environment, and they're all either 1111111 or 666666666. So there's that to deal with, but. You're perfectly right, yeah.
Hi, Daniel. This is not really a question, but a series of 4 statements. One, I really enjoy your talk.
Thank you very much.
2, you have a fantastic English accent.
Thank you very much. I
3,
try really hard.
I really hope you're feeling better, and if you're not, I can bring you a cup of tea or a blanket. And 4, please don't hack Facebook.
The thing is, so for the first statement, thank you. For the second statement, I try really hard. I actually watch a lot of James Bond films in my spare time, just for the accent. If any of you know Idris Elba, I just listen to him on my iPod. I would love some tea. I'm British. And sure, maybe. I have an actual face as well, you can tell from my face.
My question is regarding the percent you think of jailbroken phones. I've heard of game developers saying that they had really high piracy rates, much more than they were expecting. So do you have any insight on how many people are stupid enough to jailbreak their phones in general?
I don't off the top of my head. I think it's very likely that I think it's very likely that there are other speakers here which will. The reason why I tripped up there is because I forgot the name of someone that I actually know in person. But I will tell you afterwards. But yeah, I'm not sure off the top of my head. Some numbers that might be of use, for example. Actually, no, there's no point. It's a Google away there.
Daniel?
Sí.
Two statements, one question. One is great conference, thanks. Second is I jailbroke my Apple TV and didn't change the SSH key from Alpine.
You did change or didn't change?
I didn't.
Okay.
So you can
go. Are you on the network?
Home
are you on the network now?
No.
Okay.
And the question is, given that we all hate Apple review times, I would expect Apple to check or have a database of URLs for open apps from other apps. So don't collide or kind of something like that.
I don't know about that.
Have you tried to submit an app?
No. However,
don't tell Hermes.
However, so this was from a paper which I will link in the various supplementary materials. They were able to submit an app with this. Given that they published the paper, this may well have been because the Apple now checked this. I'm not entirely sure about that. If I did, I would do it on someone else's account to try.
You can't steal Facebook.
No, you can't?
Not in the App Store.
So, sure, so not on the App Store. So the comment was you can't steal Facebook's bundle ID. And this is absolutely true. Not on the apps. You can't publish this to the App Store. But you can have it, for example, with an enterprise signed or something else signed. In the ideal case where they use Facebook to authenticate and don't have the Facebook app installed, then your app will install fine. And then this can continue to work as normal. But you're absolutely right. Like that, you can't release that to the to the Apple Store. So, but that one was only for someone like Pinterest who does check the incoming bundle ID. I have one caveat to that, but I'll bring that up later with you and potentially Scott Goodson as well. Yeah.
You mentioned man-in-the-middle attacks through Charles and like self-signed root certificates.
Yes.
That doesn't work on iOS 9
You're
if
correct.
you have app transfer security enabled. Would you know why? Like what the underlying reason is?
No, I did see this the other day. Obviously, if it's an app that you yourself are debugging and you absolutely must do it with Charles, then you can disable that. I could say similarly, if you are jailbroken, you can then disable that and then sniffer it as normal. But no, I'm not entirely sure about that. I can't tell you, but very likely Daniel could, other Daniel.
Thanks.
Hi, Daniel. I really love your talk. And I'm one of those stupid users that do jailbreak to their phones. And also a developer, Cydia developer, so I make apps for Cydia. And I have to say that developing apps for Cydia is not bad. Jailbreak is not bad at all. The bad thing is that when users, bad people try to modify the system to its own benefit. For example, I make tweaks for apps to using the library depend injections to modify, I don't know, to download video from YouTube or maybe extend an app that doesn't have like some utilities, but actually it's not bad, and allow you to I don't know, if there is a book that you can understand, you can debug on there, and it's easier to, you can open SSH to the system. You have all the access to the system, but it's not bad in the good hands, you know. So it's kind of cool. And also there is a huge community of developers from Syria. I have like 2 apps or so, and one of them have that 2 million of downloads. So there is a opportunity on there too. So you can make money. Actually, there are people making a lot of money by Syria apps. You can sell on Syria. There is Saurik, is the developer of Syria, and there is an app store inside Syria, and you can develop tweaks and sell of them, all of them. So I started working at Syria, I make money on Syria, so it's a good opportunity for developers that, I don't know, your app can be on the App Store. So, just
I agree.
That's it. That's it.
Cool. Okay, thank you very much.